long hair and you rubbed it against your hair, this is how I go to bed, so this is how I came today. I very much enjoyed pajama day. I did change this morning. I didn't but when you have long hair, you can see that your strands stick to the glue. If you don't, you can rub it enough so that it actually, without the wind at least, it actually clings to your hair. Actually, what happened was it clung to my desk. Let me see if I can get it to cling to the whiteboard. You can use enough, if you can get enough friction, and now of course my hair today just emphasizes the fact that I'm in pajamas. Let's see if this works. Okay, so I've got enough charge on it so that it, without the wind, would stick to the whiteboard somewhat. So if I wanted to get rid of that charge, what do I have to do? What did you come up with within your group? Soko. You can put it onto wood. Anything else? Alec? Metal? So we've got a concept called grounding. And all of my volunteers said we needed to touch something. So that the concept of grounding is when you touch something that is a conductor, meaning it is able to transfer charges pretty easily. It'll allow the extra charge that we built up through friction, because we rubbed it on our hair, or you can rub it on your sweater or your clothes and get it to stick. But it allows that extra charge to travel out of the object. And the ultimate grounder is earth. Everything tends to want to be neutral, meaning it wants the same amount of charge, positive charges, as it has negative charges. And if you have extra charge, that extra charge repels each other, so that if I touch something, that extra charge is going to travel out of the person or the object and down into the earth. The earth is like a vat of endless charge. It can collect and transfer charge infinitely because it's so huge. But when you have grounding, it basically means that through contact, charges transfer out of the object to become neutral. And we've got certain objects that are better conductors and are allowing charge to travel through much better than others. And we're going to go through those list of items. But someone said metal. Metal is definitely a good conductor. It allows electrons to travel through much better. There's some plastics that are good conductors. Things like your hair or fur, those like to stay positive. So that's the reason why the hair, which likes to stay positive, versus the rubber on the balloon, which likes to stay negative, end up attracting each other. So let's get into questions. Did anyone have any questions on electricity that they're curious about and are hoping to learn in this unit? Nobody? Any questions? I mean, we use electricity all the time. Adele? Sure. How protons and electrons work. had a student ask me in first period, how did they even decide what a proton and an electron was? How do they know that it's not flipped? So we're going to talk about that as well. Any others? I had some students ask questions about how electricity can be used as a stable energy. Is there parts of electricity that is not good for the environment? A lot of kind of things that might be applicable to life in general. So you want to think about those types of questions in terms of the future of our Earth. Any others that we want to add here? Okay. I will probably address a lot of the questions that you may have that you did not put up here. But if anything comes up, I'm happy to look into it. A student asked about diodes, and I don't know much about diodes, so I told them that I would try to incorporate it into the lesson somehow and make sure that we cover diodes. So feel free to ask, or if I don't know, I'm happy to look into it. But we are just today going to talk about the basics of protons and electrons.